All right, let's take a look at our practice test. For the instructions, we're asked to derive the given identities. For the first problem, we have cosine of 2a. So here's where we're going to go back to the little handout. And if we scroll down on this guy, we can come down to this section right here where you see the double angle identities. And you see the cosine of 2a is equal to cosine squared a minus sine squared a. And then you have these other forms, but I'm just going to do this one. These you can get by algebraically manipulating this one. So let's go back. And the first thing I'm going to do is just write this as the cosine of a plus a. So a plus a is 2a. Now what I'm going to do is use my sum identity for cosine. So I'm going to say that this is the cosine of a times the cosine of a. And then again, if this is a plus, you want a minus. So now we have the sine of a times the sine of a. So real easy here. Cosine of a times cosine of a is going to be cosine squared a. And then minus sine of a times sine of a is going to be sine squared a. So that's all it is. Okay, let's look at problem 2. So now we have the sine of 2a. And again, coming back to the handout, we have the sine of 2a is equal to 2 times the sine of a times the cosine of a. So that's what we're looking for. So to start out, I'll say this is equal to my sine of, again, a plus a, just like we did in the last example. A plus a is 2a. And so this is equal to, again, you just use your sum identity for sine. So we'll say this is the sine of a times the cosine of a. And then the sign here is always going to be the same. So this is a plus, so I want a plus. And then I want to do the cosine of a and then times the sine of a. So what is this equal to? Well, basically I have the sine of a times the cosine of a, and then I have the sine of a times the cosine of a. Remember, you can multiply in any order. So I could flip this around and say that this is the sine of a times the cosine of a as well if I wanted to. So let me actually write it like that. So this is the sine of a times the cosine of a, and then plus the sine of a times the cosine of a. So that means I have 2 of this guy right here. Right? So I could just say this is 2 times this sine of a, and then times the cosine of a. So that's our formula. Okay, let's take a look at problem 3. So we have the tangent of 2a. Let's go back to our handout and come down to this guy right here. So the tangent of 2a is equal to 2 times the tangent of a over 1 minus tangent squared a. So another real easy one to get. So just start out by saying this is the tangent of a plus a. And so this is equal to what? Use your sum identity for tangent. So this is the tangent of a. And then remember, this sign is always going to be the same. So this is plus your tangent of a, and this is over 1, and then this sign is different. So this is a plus, you want a minus. So you have the tangent of a, and then times the tangent of a. So a real easy formula. Tangent of a plus tangent of a is just going to be 2 times the tangent of a. Then this is over. You have 1 minus tangent of a times tangent of a is tangent squared a. All right, let's take a look at problem 4. So we have the cosine of a times the cosine of b. And so if we look at our little handout and we come down to the product to sum identities, I'm not going to derive all of these. I'm just going to do the first one. The other ones you can get using a similar strategy. So for this one, we want to end up with 1/2 times this quantity. You have the cosine of a plus b, and then plus the cosine of a minus b. So what I'm going to do to get this formula is start out with the cosine of a plus b, and then plus the cosine of a minus b. And we'll just see what happens. So let's come up here, and I'm going to start with the cosine of a plus b. And this is equal to the cosine of a times the cosine of b. And then if this is a plus, you want a minus. Then you have the sine of a, and then times the sine of b. Okay, let me do the other guy. So we have the cosine of a minus b. So it's the same thing as this. You're just going to change the sign in the middle. So this is the cosine of a times the cosine of b. Now this is a plus. You have the sine of a and then times the sine of b. So for the next step, what I'm going to do is just add the left sides, set this equal to the sum of the right sides. So here you would just write this as the cosine of a plus b, and then plus the cosine of a minus b. And then what's going to happen here is this is equal to this plus this. You have cosine of a times cosine of b plus the cosine of a times the cosine of b. Well, that's just 2 times the cosine of a times the cosine of b. Now this part right here is going to cancel away, right? You have the negative of sine of A times sine of B plus sine of A times sine of B. That's just going to be 0 and go away. So at this point, we're almost there. We need to divide both sides by 2, or you could multiply both sides by 1/2. So let's just go ahead and say, and I'm going to flip this around, that this is the cosine of A times the cosine of B. So that's what we're trying to figure out. And this is equal to, I'm going to go 1/2 times this guy right here. So the cosine of A plus B, and then plus your cosine of A minus B. All right, for the next few problems, we're asked for the instructions to find the exact function value. So for problem 5, we're given that theta is in quadrant 2, and we want to find the sine of 2 theta. So before we do any work, let's just come back down to the handout, and I'm going to go to the double angle identities, and you see for the sine of 2a, you have 2 times the sine of A times the cosine of A. So let's write out that the sine of 2 theta is equal to 2 times the cosine of theta times the sine of theta. Now we're given the tangent of theta, and this equals negative 12 over 5. Okay, how can we find the sine of theta and the cosine of theta so that we can plug into this formula here and figure out the sine of 2 theta? Well, the easiest way here is probably just to go back to our original definition. We know that if I'm in quadrant 2, the x values are negative and the y values are positive. The tangent is going to be your y over your x. So what we'll say here is that the x value is negative 5 and the y value is positive 12, right? So this is basically 12 over negative 5, which gives me the negative 12 over 5. Now, what's the r value? Without even thinking about it or going into any detail, most of you know, forget about the fact that this is negative, you have a 5, 12, 13 right triangle, right? That's a special right triangle. But again, you can go through and crank this out. R is equal to the square root of x squared plus y squared. So my x is negative 5. Negative 5 squared is 25. And then my y is 12. 12 squared is 144. And then 25 plus 144 is 169. And then if you take the square root of 169, you will get 13. Okay, so that's where you get that. Again, if you recognize that you have a 5, 12, 13 right triangle, then just throw 13 in there and be done with it. All right, so the next thing I would think about here is building my sine of theta. So that is y over r. In this case, your y is 12 and your r is 13. And then my cosine of theta is x over r. In this case, my x is negative 5. Let me put the negative out in front. And then my r is 13. Okay, so we have the sine of theta. We have the cosine of theta. So if we want to figure out the sine of 2 theta, again, just plug into that formula. So let me write this down here. We're going to go off the screen. Let me come down here and say that my sine of 2 theta is equal to 2 times the sine of theta is 12 over 13, and then times the cosine of theta, which is negative 5 over 13. So this gives me, nothing's going to cancel. So 2 times 12 is 24. 24 times negative 5, that's going to be negative 120. And this is over 13 times 13 is going to be 169. So the answer for the sine of 2 theta, it's going to be the negative of 120 over 169. All right, let's take a look at problem 6. So theta is in quadrant 2. We want to find the cosine of 2 theta. And going back to the handout, you have this one that says the cosine of 2a is equal to 1 minus 2 times the sine squared a. I would use that one in this case. So let me slide down here a little bit. And I will just say that the cosine of 2 theta is equal to 1 minus, you have 2 times sine squared theta. So let's just plug in here. So for the sine of theta, it's going to be the square root of 231 over 20. So the square root of 231 over 20. And then we need to square this. So what's that going to give me? Well, let me write, this is 1 minus 2 times the square root of 231 squared is just 231. This is over 20 squared is going to be 400. Now what I can do is cancel a common factor between here and here. So 2 divided by 2 is 1. 400 divided by 2 is 200. So this would be equal to, let me write this with a common denominator. So 200 over 200. And then minus, you'll have 231 over 200. So this would be equal to 200 minus 231 is negative 31. and this is over the common denominator of 200. So this would just be negative 31 over 200 for the cosine of 2 theta. All right, let's take a look at problem 7. So now we're told that theta is in quadrant 4, and we want to find the cosine of 2 theta. So here we're given the cosine of theta, and this is 5 over 13. So going back to the handout, I would pick this guy right here where it says cosine of 2a is equal to 2 times cosine squared a minus 1. So let me say that the cosine of 2 theta is equal to 2 times cosine squared theta and then minus 1. So coming down here, I'll just replace this cosine squared theta with 5 over 13, and then I'm going to square that. So that gives me what? Let me scroll down here just a little bit. I will say that this is 2 times 5 squared is 25, and 13 squared is 169. Nothing to really cancel there, so let me just write this right now as 50 over 169, just doing that multiplication of 2 times 25. And then minus, let me get a common denominator. I'll say this is 169 over 169, and this equals 50 minus 169. Let's do that on the calculator, and you're going to get negative 119. So let's say this is negative 119 over 169. Now this is not going to simplify any further, so this is going to be your answer for the cosine of 2 theta. All right, let's take a look at problem 8. So now we're told that theta is in quadrant 1. Find the tangent of 2 theta. So there's a lot of strategies for this. You have your tangent of 2a is equal to 2 times the tangent of a over 1 minus tangent squared a. So you could use that formula if you want. So basically you could find out what is the cosine of theta, and then you could build out your tangent of theta, and then you can plug into the formula to find the tangent of 2 theta. You could also find the sine of 2 theta and the cosine of 2 theta, and then you could just do the division, find the tangent of 2 theta. So whatever you want to do, I'm just going to go with the first route here. So I would notice that this is going to be an 8, 15, 17 right triangle, right? I'm in quadrant 1. And again, if you don't know that, you can think about sine of theta as y over r, right? So my y value is going to be 15, and my r value is going to be 17, okay? So you could just plug in to the r is equal to the square root of x squared and then plus y squared. Now I know that y is 15, so this would be 225 here. And this would be 17 here. You've got to get rid of the square root. So what I would do is square both sides. So this would be 289 over here. And if I square this side, this would go away. Subtract 225 away from each side. You would end up with 64 is equal to x squared. And again, we're going to be in quadrant 1, so my x values are going to be positive. So I would want the principal square root here, and I would just say that x is equal to 8. Okay, but again, if you notice this is an 8, 15, 17 special right triangle, then you can just immediately say that x is 8 there. Let me get rid of this, and I'll just say that x is going to be 8. So now cosine of theta is x over r, so it's 8 over 17. So very simple. Let's get rid of this and come down here. And for the tangent of theta, it's your sine value, so 15 over 17, divided by your cosine value, so 8 over 17. I'm dividing with fractions, so take the first fraction, multiply by the reciprocal of the second fraction. And so we see that this is going to cancel, and I have 15 over 8. All right, so for the tangent of 2 theta, it's going to be 2 times your tangent of theta over 1 minus tangent squared theta. So the tangent of theta is 15 over 8. And then tangent squared theta, so that's 15 over 8 squared. Okay, let me make this a little bit better here. Now, you can go through and say that this 2 would cancel with this 8 and give me a 4. 15 squared is 225, and 8 squared is 64. So this is 225 over 64. Let me get rid of this and write this more cleanly. What I would do is multiply the numerator by 64 and the denominator by 64. That'll clear all the denominators out. So let me show this like this. So this would be equal to 64 divided by 4 is 16. 16 times 15, that's going to be 240. And this is over. You would have 64, and then minus the 64s would cancel there. You're 225. So this would be equal to 240 over 64 minus 225. It's going to be negative 161. So that would be your answer. You're not going to be able to simplify that any further. So the tangent of 2 theta is negative 240 over 161. All right, for the next few problems, the instructions tell us to verify each identity. And for problem 9, we have 2 times sine squared x times the quantity 1 plus cotangent of x is equal to sine of 2x minus cosine of 2x plus 1. I'm going to flip this for formatting. So I'm going to put that we have the sine of 2x minus the cosine of 2x plus 1 is equal to this 2 times my sine squared x times the quantity 1 plus the cotangent of x. Okay, so here's how I'm going to do this. I'm going to make this right side match this left side. Let me put my equals over here so I have some room. We'll slide down a little bit. So I'm going to distribute this in. So I'm going to say this is 2 times sine squared x, and then plus, you would have 2 times sine squared x times cotangent of x. Now, the cotangent of x is the cosine of x over the sine of x. So let's write this as 2 times sine squared x plus 2 times sine squared x times cosine of x over sine of x. Now I can cancel one of these with this. So now if you look at it, you have 2 times sine of x times cosine of x. Going back to our handout, if I have 2 times the sine of a times the cosine of a, that's the sine of 2a. So I want to replace this with the sine of 2x. So I'll say that this 2 times the sine of x times the cosine of x, this is going to be the sine of 2x. So at this point, I have this part right here. What I need is this negative cosine of 2x plus 1. So how do I get that? Well, look at this 2 sine squared x and come back to the little handout. See this guy right here where it says cosine of 2a equals 1 minus 2 times sine squared a? Let me write that out. So if we have the cosine of 2a, this is equal to 1 minus 2 times sine squared a. So what I'm going to do is subtract 1 away from each side. So let me put minus 1 here and then plus this here. And I'm going to get rid of this from here. And then just multiply both sides by negative 1. So this would now be a plus and this would be a minus. And this is what I'm going to substitute in for this right here. That way I can get my positive 1 and my negative cosine 2x. Okay, this is exactly what I want. So I'm going to say that this is equal to here, this 1 minus the cosine of, in this case we're working with x, so cosine of 2x. Let me get rid of this, and then you could just reorder it to make it match this guy right here exactly. So I'm just going to say that this is equal to, you'll have your sine of 2x, and then minus your cosine of 2x, and then lastly, plus 1. And so we verified our identity. Let me just put a check mark to show we're done. All right, let's take a look at problem 10. Here we have our cosecant squared x over sine squared x plus cosine of 2x. This is equal to tangent squared x plus 1 over sine squared x. All right, I'm definitely going to think this side is simpler. So let me write this again. So I'll say this is the tangent squared x plus 1 over my sine. Let me make this a little bit better here. So my sine squared x. This will be equal to cosecant squared x over sine squared x plus cosine of 2x. Okay, let me put equals all the way over here. So remember at the beginning of the practice test, we derived this guy. So the cosine of 2a is equal to cosine squared a minus sine squared a. So I'll say this is cosecant squared x over sine squared x. And then plus cosine of 2x, I could write as cosine squared x minus sine squared x. And make this a little bit longer here. Now, sine squared x minus sine squared x is going to be 0. Right? So this and this, those are going to cancel. So let's say now this is equal to the cosecant squared x over cosine squared x. Now, if you think about what you have here, you have sine squared x in the denominator. Well, here it's cosecant squared x, which is 1 over sine squared x. So you can immediately do that one. So I'll go ahead and say that this is 1 over sine squared x, and then times, you have 1 over cosine squared x, which is really secant squared x. Now, you're trying to get tangent squared x plus 1 in the numerator. Secant squared theta is equal to tangent squared theta plus 1. So coming back down, I'll go ahead and say that secant squared x is tangent squared x plus 1, and we'll be done. So we'll say that this is tangent squared x plus 1 over sine squared x. Let me make this a little bit better so we don't think this is 2x. So this is a squared here. And so we're done here. We verified our identity. So let me put a check mark there. All right, for the next few problems, the instructions tell us to find the exact value of each expression. So for problem 11, we have 3 times cosine of 5 pi over 12 times sine of 13 pi over 12. So we're going to come back to the handout and come down here to where we have our product to some identities. So in this particular case, we have cosine of some angle times sine of some angle. So it looks like we want to use this last formula here. So I'm just going to copy it down and come back. So we have the cosine of A times the sine of B is equal to, let me scooch this down a little bit so it fits, or actually I'll just write it down here. So this is going to be 1/2 times, you have your sine of A plus B, and then minus your sine of A minus B. Okay, so let me close this down like this. So this is what we want to do. Let me scroll down here a little bit, and you're just going to plug into the formula. It's pretty easy overall. So first off, you have this 3. Just put that outside for now. So I'm going to put the 3 outside, and you can use brackets or parentheses or whatever you want to do. Then you have the 1/2, and then let me use brackets again. So you have your sine of A plus B. So this is your A, this is your B. So you would have 5 pi over 12, and then we're going to say plus 13 pi over 12. Let me make that 13 a little bit better there. And let me put an equals here and just drag this over here so we know what's going on. And then we'll put minus the sine of A minus B. So this is your A, this is your B. So you have 5 pi over 12, and then minus 13 pi over 12. And let me close down the brackets here. So we have this one, and then we also have this one. So you have 2 sets of brackets. And so what we'll do from here is say this is 3 times 1/2, which is 3/2. Put my brackets in there. So this would be the sine of 5 plus 13 is 18, and 18 over 12, each is divisible by 6. 18 divided by 6 is 3, and 12 divided by 6 is 2. So this is 3 pi over 2. Okay, so you want sine of that, and you don't need parentheses here. And then minus the sine of, you're going to have 5 minus 13, which is negative 8 over 12. Now forget about the fact that it's negative. If you have 8 over 12, 8's divisible by 4. 8 divided by 4 is 2. And then 12 divided by 4 is 3. So this would be 2 pi over 3. Now, it's a negative here. And remember, sine is an odd function. So I can pull the negative out and basically change this minus here into a plus. Okay? So then I'll put this as being closed down here. So we have our 3/2 on the outside of the brackets. Hopefully you know that the sine of 3 pi over 2 at this point is going to be -1. So this is -1. And then plus sine of 2 pi over 3. Remember, 2 pi over 3 is 120 degrees. So the sine of 120 degrees, you have a 60-degree reference angle. The sine of 60 degrees is square root of 3 over 2. You're in quadrant 2, so it's going to be positive. So this is the square root of 3 over 2. Let me close that down. So you could add inside the brackets first, or you could distribute. Really doesn't matter. So let me just go ahead and distribute this. I'll say this is -3/2, and then plus, this would be 3 times square root of 3 over 4, right? 2 times 2 would be 4. So now let's just write this with a common denominator. I'm going to multiply this by 2 over 2. And so that would give me -6 plus 3 times square root of 3 over 4. All right, let's take a look at problem number 12. So we have -3 times the quantity, sine of pi over 12, plus the sine of 5 pi over 12. Okay, so let's go back to the little handout. And in this case, what you're going to want is this first guy right here. So sine of A plus sine of B equals 2 times the sine of A plus B over 2 times the cosine of A minus B over 2. So let's scroll down just a little bit. I'll put the -3 out in front. And then again, for the formula, it's 2 times the sine of, you're going to go a plus b over 2. So this guy plus this guy over 2. So let me go pi over 12 plus 5 pi over 12 over 2, like this. So let me just stop and do this now so it doesn't get so messy. So we know that we have a common denominator. 1 pi plus 5 pi would be 6 pi. So this would be 6 pi over 12. So 6 pi over 12. And I'm dividing by 2, so that's the same thing as multiplying by a half. And so here, let's just go ahead and cancel this with this. And that is going to give me a 3 up here. And then 12 divided by 3 would be 4. So this is going to end up being pi over 4. Okay, so we'll want 2 times sine of pi over 4. So now you're going to have times the cosine of, you want this angle minus this angle. So now we want to go pi over 12 minus 5 pi over 12. And then we're going to divide by 2. So 1 pi minus 5 pi would be negative 4 pi. So this is negative 4 pi over 12. Again, I'm dividing by 2, so this is the same thing as multiplying by a half. And so I could cancel here first or here first. It doesn't really matter. So I'm going to cancel this with this and say I have negative 2. So then 12 divided by 2 would be 6. So this is going to end up being negative pi over 6. So this is negative pi over 6. Now, cosine is an even function. So the cosine of negative pi over 6 is the same as the cosine of pi over 6. So you can get rid of this negative if you want. Okay, let's close this down. And from here, it's pretty easy overall. You would say that this is negative 3 times, you have your sine of pi over 4. So pi over 4, again, is 45 degrees. And for the sine of 45 degrees or the cosine of 45 degrees, it's square root of 2 over 2. So this is 2 times square root of 2 over 2, and then times the cosine of pi over 6. So pi over 6 is 30 degrees, and the cosine of 30 degrees is the square root of 3 over 2. Let me close this down, and we'll keep going. So this is going to be negative 3 times, you can just drop the parentheses at this point because it's all just straight multiplication. So we would have this 2 canceling with this 2. So let's put the square root of 2, and then times the square root of 3, and this is all going to be over 2. Now, if I finish this up, I'll just say that this is negative 3 times the square root of 6, square root of 2 times square root of 3, square root of 6, nothing you can really do with that, over 2. So this is as simple as we can make this. So you could say the negative of 3 times square root of 6 over 2. All right, for the next part, the instructions say to write the product as a difference. So for problem 13, we have the cosine of 8 theta times the sine of 2 theta. So this is a product right now. We're multiplying these guys together, and we want to write it as a difference. You want to go up to the product to sum. So right now, you want to use this one. The cosine of A times the sine of B is 1/2 times the quantity sine of A plus B minus the sine of A minus B. So this is equal to 1/2 times, again, you're going to have this quantity where you do the sine of A plus B. So this is A and this is B. So 8 theta plus 2 theta. Let me write this out so nobody's lost. So 8 theta plus 2 theta. And then basically from there, you're going to go minus. You're going to have your sine of now A minus B. So this would be 8 theta and then minus 2 theta. Let me close this down. So let me say this equals, you have 1/2 times this quantity. The sine of 8 theta plus 2 theta, we could just say this is the sine of 10 theta. And then minus the sine of 8 theta minus 2 theta would be 6 theta. So I'll just distribute the 1/2 to each guy here. So this would be sine of 10 theta over 2 minus sine of 6 theta over 2. And of course, you could write that with a common denominator if you wanted to. So you could say this is the sine of 10 theta minus the sine of 6 theta over 2. All right, for the next guy, the instructions say to write the sum as a product. And for this one, for problem 14, we have 2 times the quantity sine of 13b plus the sine of 3b. So right now, this is a sum, and we want it as a product. So let's come back, and we want to look for the sum to product identities. So we have the sine of A plus the sine of B. So this is the one we want. So it's 2 times the sine of A plus B over 2 times the cosine of A minus B over 2. Okay, this one's tricky because you have a 2 already out front. So don't make the mistake of just putting 1, 2, you need a 2. And then the formula is 2 times your sine of A plus B. So this is your A and this is your B. So this is A and this is B. So I'm going to go 13B plus 3B, and this is divided by 2. And then you have times your cosine of, now you're going to do A minus B and divided by 2. So 13B minus 3B, and this is divided by 2. Let me close this down and close this down. So let me go 2 times, you have 2 times the sine of 13 plus 3 is 16. 16 divided by 2 is 8. So this is just 8b. Let me drop these parentheses here. So this is 8b here. And then times the cosine of 13 minus 3 is 10. So this would be 10b over 2. And 10 divided by 2 is 5. So this is the cosine of 5b. So close this down. And to finish this up, 2 times 2 would be 4. So this is 4 times the sine of 8b times the cosine of 5b.